suppose that a function f from 0 to 1 r is continuous and the function is never 0 for all x between 0 and 1. Further suppose that we have this identity that the function squared is equal to 2 times the integral from 0 to x of f of t dt for all x between 0 and 1, and we're proving that f of x is equal to x. So we have this identity function for all x from 0 to 1. We're going to use the fundamental theorem of calculus because there's a nice integral here. And we're going to take this identity and we're going to take the derivative of both sides. So taking the derivative, this gives us 2 times f of x, f prime of x, using chain rule, is equal to, let's see, 2 times derivative of that integral is just f of x. Thinking about fundamental theorem of calculus. And we have a 2 f of x here and a 2 f of x here. I'm going to divide that on both sides to get f prime of x is equal to 1. And now I'm going to integrate both sides. So the integral of the derivative gives me the function back, and the integral of just 1 gives me x plus some constant c. Okay, and now we have this property that we haven't used yet, which is that the function is never 0. So, we use this because this allowed us to divide the f of x. Yes, this allowed us to divide the f of x. So actually we want to look at this identity and we want to note what happens at 0. So we're going to note f of 0 squared is equal to the integral from 0 to 0 of f of t dt. But from the fundamental theorem of calculus, the integral from 0 to 0 is just 0. And this implies that if we took the square root, we just get f of 0 equals 0. Okay. So now what we can do is plug in 0 into this identity that we have. And so we have f of 0 equals 0 plus c, which is equal to c. But we know that f of 0 is 0, so we know that c equals 0. So f of x is equal to x for all x on the interval 0 to 1, using the fundamental theorem of calculus. Proof is complete.